and A is that. So it's just m1 times T3 divided by the sum of the masses. And since you know all those numbers, you can find that out numerically. And then you can solve for T2 likewise. T2 is just going to be mass 2 times A, which you know, plus whatever you get for T1, etc. Okay, so that's for T1 and T2. And one thing you should notice is that if you just look at this number out front here, this is less than T3, because this number is less than that. So in fact, you have something that's flowing to the right here with 65 newtons. And then this T2 will be a little less than that, and T1 will be a little less than that. So what that means is that if you have this like chain of people that are being held together, and the guy on the right is pulling everybody, your left arm is going to feel a lot of force, more so than your right arm. And the guy after that, he won't feel as much force with his arms, because he's really more flow back. And the guy after that won't feel that much arm, compared to the guy's pulling. So even though it's like it's all connected, it really these have to be more, because overall you've got to have acceleration that way. So your total force has to have has to be bigger than that. Are there any questions on that problem? I didn't get the numerical answers, but solving it is just plugging in numbers. Okay, so let me do the elevator problem up there, and then I'll do a problem with angles in it where you have to choose the right point system. And then I'll call it a night. The problem I'm doing is number 33 in chapter 5. The problem says this. It says an elevator cab and its load have a combined mass of 1,600 kilograms. We go to the elevator. And they're originally moving downward at 12 meters per second. So this thing is moving down like this at 12 meters per second. And it's brought to rest with a constant acceleration and a distance of 42 meters. So basically it's like, as if you're in an elevator, and you're going down, you're slowing down, and after 42 meters you stop. I think I changed my number to 15 in the homework.
Yeah.
Okay. And the question is asking, find the tension. Okay, so there's this cable holding it up. Now, because you're asked to find a force, you're going to most likely have to use Newton's second law at some point. So let's write out the equation of Newton's second law, which means we first have to write a coordinate system and then draw a free body diagram. So we draw the coordinate system first. Obviously, I would make it like that. There's no angles, so just make it like that. Well, everything in the y direction, pretty simple. And the free body diagram, again, it's also pretty simple. It has two forces. Tension pulling it up, supporting it, and then the weight just always acting on it in the direction of gravity. So if I write down Newton's second law, I'm going to have T minus W equals MAY. Now in this case, the acceleration is not zero. It's telling you it's a uniform acceleration. But you're actually slowing down, so there has to be some acceleration. So the right-hand side is non-zero, so you have to find it. So I'll plug in mg here. So the question is, what is tension? Well, tension equals mass times acceleration plus mg, if you look on that side. And we know what the mass is, but we don't know what the acceleration is. To find acceleration, we have to go back to kinematics, which is chapter 2. And it gives us a little bit of information to find out what the acceleration is. It tells you one thing that's very important, which is that its acceleration is constant. That's very useful. And the second thing it tells you is what the initial velocity is. So hopefully you can find accelerations then. Are there any questions on how I got this first of all before we go on to it? It's just an application of Newton's second law. But I saw a lot of questions on the discussion board that were like, well, I just said these things equal, I didn't get the right answer. But just writing down Newton's second law and not plugging in zeros unless it's actually zero is critical. Just writing this down and asking yourself what you know, what you do not know, and what may or may not be zero is the first step. Once we have that, we can find out what we need. The acceleration can be found by using the equation for a constant acceleration, which is 1/2 mt squared plus v y t, sorry, v naught plus y naught. So let's see what we have. Again, we're looking for ay. So we need to have all these other variables to solve this. And if we don't, we might want to use a different equation, or we might want to combine some equations. Let's see what we have first. 15 meters per second. Well, I drew my coordinate system up like that, so that's going to be my initial velocity is negative. So initial velocity in the y direction is negative 15. What else do I know? Okay.
Y0 is Y naught is 0.
Y naught is 0.
Y is 42.
Okay, I'm gonna so y naught could really be depending where you put your origin. I would always put my origin at the ground because it makes things easier for me. So I'm gonna say that y naught is actually positive 42. That's ambiguous, you can do it either way. I'll do that. So you're starting at 42 meters high, and you're ending at 0, so y is 0. Y final is 0. Anything else? There's one more piece of information.
G. T.
Let me see what it says.
Time.
An elevator cab and its load have a combined mass of 1,600 kilograms. Find the tension when the cable, originally moving downward at 12 meters per second, is brought to rest with constant acceleration. It's brought to rest.
So the final law is zero.
So the final law is 0. Okay, so we have distances and velocities. This equation may not be useful because of its times. There's a third equation that does relate those, which Professor Farr said you don't need to memorize, but I think it's useful to memorize, my opinion. Which is this equation. 2a is it plus? Okay. I just wrote that in terms of y. Now that's useful because we have everything that's equated to solve it. So Vy we know is 0. A is negative 9.8. Y is 0 and y naught is 12, number 12. And then V naught y squared is 15 squared. And you can solve this for A.
The only finding accelerations is on a table. So
Yeah, thank you. Why did I think that? So A is not G. A is actually unknown.
which is zero. Y is 42.
Oh, thanks. Is that right? Okay. So yeah, thank you. Acceleration is not gravity. It's not free falling. There's something that's important. And you can solve that for A well. I got a question. And I actually want to use this as a quicker question. So the question is this. And I don't know if this is right or not here. We might have messed up the science. So I'm going to ask you guys intuitively, what do you think? Is acceleration, is it positive or is it negative?
Negative.
Is acceleration positive or negative? Let me take a poll. Yeah, in this situation. With this coordinate system given, and the exact same information. And pretend like we don't know if that equation is correct. You can solve it to get a positive or negative number, which is conceptually, does it seem like it should be positive or negative? Yeah, it's this way. again, the acceleration, do you think it'll be positive or negative? Elevator's going down, slowing down, until it comes to a rest. Another 10 seconds. I think that's probably everybody. So, seems pretty close. Looks like half you guys think it's positive, half you guys think it's negative. Actually, you know what? We have a little bit of time. So why don't you take like 60 seconds and just turn to a neighbor, know them, talk to them. If you don't know them, introduce yourself. And,
How's it going?
try to convince them of why you think it's positive. We'll come back
I think
and
it's positive or negative?
Maybe I might have rushed because I really didn't look at it. But if I'm looking at the coordinate system,
Yeah.
I'm thinking because it is well, the elevator is going down and acceleration is going down, so it's got to be positive.
I was thinking it'd be negative because the tension is pulling it up. So, because the tension is pulling it up, that the acceleration, if it was positive, would go with the tension. Since it's the tension, since it's going the opposite of the tension, then it's actually negative acceleration. That's why I was thinking it'd be negative.
Yeah. True. So you're saying it's pulling up against
It's going against the tension.
tension is positive, but acceleration is negative.
So if the acceleration was positive, it would go with the tension. So since it's negative, it goes against the tension. That's just,
Yeah, sure.
I don't know. Could be wrong. I'm Tim, by the way. What's your name?
D'Angelo.
D'Angelo?
Just D.
D? Yeah. Nice to meet you.
And you too.
Okay, so if you have any, go ahead and put an answer. What do you think now? If you think it's the same, go ahead and show the same answer. If your mind has changed, we'll be there. And we'll come back to class and see if you guys are convinced each other of the right answer. This is a tricky question. I think about this too. Is that Virginia? One more time. Okay, I'm gonna go and stop it. And here's what we have. It's more skewed towards positive, which is correct. So, actually, some of you mind changed. Can they explain to me what changed your mind? Before it's not negative and now positive instead. Maybe don't break. Yeah, some of you. Oh, okay. Okay, so she said velocity is decreasing, so for it to go to a stop, acceleration has to be positive. But when I think of velocity decreasing, I think of something with a negative slope. So to me, that would suggest that it'd be a negative acceleration. So she's on the right track, but I don't know if I agree with her reasoning. Tell me your name.
Daniel,
Daniel, what do you think?
as the velocity approaches zero, then you want it to be going in the opposite direction.
Okay, so I think you guys you have something in common. Shabot's saying that the velocity seems to be getting to be closer to zero, which is somehow affecting the acceleration. Let me get one more. Yes, what are your name? Motion is the same direction as gravity, so positive. Yeah. Okay, so here's how I think about it. It's all good ideas. Here's how I think about it. I would think about how velocity is changing over time. This may not be the only way to think about it. What is the velocity at the very beginning? 15, right? What is it at the end? 0. So it's in line with the positive slope, so the acceleration is positive. That's how I would think about it. And you know it's linear because it's constant acceleration. Acceleration is a positive number. The other way to think about it, which I think I heard in many responses, was that the velocity is going in one direction, but it's slowing down in that direction, so acceleration has to be pointing in the opposite direction, which I think it is. And I think I heard that in other answers too. So velocity is going down, but it's getting less in that direction, so acceleration has to be in the opposite direction, meaning acceleration is up. If that's not obvious to you, always just go back and think about how the velocity is changing, and I would just draw a simple graph. Here acceleration is positive. And if you look at this, we should get a positive number. Yeah, I think we do. So we got AY times 2 times 42 equals 225. And you can solve for A. This is 225 divided by 84. Once you have A, you can plug it in here and find the tension. So again, to recap this problem, the question was asking what is a tension, which is a force. So I used Newton's second law, and I wrote down the equation for Newton's second law. And I found that the tension depends on the acceleration. Then we went back and used kinematic equations to find the acceleration, given what we knew about the velocities and the distances. Any questions on this problem? Yeah. Why didn't I? Because that's only the case when it's just freely falling. But in this case, there's a cable support here. So the acceleration will be different. So if the only force acting on it was gravity, this acceleration will be gravity. But it's not, because if that's changing its acceleration, it's slowing it down. It's a combination of both. In fact, over here you'll see that the tension. So it depends on what that value is. Are there any other questions on that problem? Yeah.
Just real quick, for when you're finding the final answer, would the G, or the gravity not be negative or positive?
Oh, yeah, good question. So he asked me, what are the G in this question? Again, to make clear here, when I drew this vector down, and I put a negative here, I've already taken into account the fact that G is negative. So when you plug in G here, do not plug in a negative number. Plug in a positive number. And in fact, whenever you do force diagrams, I would always put the negatives whenever you start drawing these vectors, and you write this first, second law. After that, everything you plug in is positive. And it's so there's 5 more minutes. I think I'm just going to stop now. If you have any questions, anything else? Go ahead and
Did you already submit the homework?